Okay, hi students. We're going to enter the second week of our class. So, in this week, we're going to focus on two concepts which are kind of like abstract. They're called inheritance and polymorphism. So in my opinion, inheritance is of a higher importance to you because so when you go to your job, so when you are going to handle a big project, you have to use inheritance in a lot of occasions in order to save the amount of efforts that you pay at programming. So basically, inheritance provides a very convenient way for you to reuse a part of the code multiple times. So let's see what it is. Uh, so first, if we look at the content in chapter 9, we are going to say how to create subclasses and how to override some methods and class hierarchies and also visibility. So when you are going through the content, you should only focus on the first five of them. And uh, among them, the first two sub chapters are really important for you, whereas the other parts like the class hierarchy or designing for inheritance, these are the things that I would say you should learn more from them. You should learn more about them from your practice in a real world project rather than from textbooks or some like programming assignments. So these are the things that definitely require someone. It's pretty much like if you have an internship and you are in a team, and then you should have a mentor. So your mentor is going to be the best person to teach you how to design your code by leveraging inheritance and class hierarchy. So because you are going to have the context, which is the real world problem, for you to think about it. Okay, so first let's see what is inheritance. The inheritance is pretty much like in real life. Say when someone passes away, then his sons or his like grandchildren are going to inherit his wealth. Okay, in our in our programming language, most of them like C++ or Java, whenever there is the concept of object oriented programming, in most cases we have inheritance. Inheritance allows you to do this. Okay, suppose here you define class called say so we use this diagram to show the inheritance, but I'm going to let you say this. Okay, to say this example, suppose okay here you have already defined your class vehicle. Okay, for example, okay, here you have different properties of your vehicle, like the engine, or let me say you have your engine. Let's use string. Okay, this variable tells you what kind of engine do you have, like V6, V7, whatever, and then it has say transmission. Okay, so okay, you define your class called vehicle, and so what you know is that okay we have different subtypes of vehicles, like cars, like pickups, like trucks. Okay, so there are different types of them. So we can have cars, we can have like say pickup, we can have trucks. Okay, so each kind of like each subtype may have a special property. So for example, if we consider cars, okay, first all of them, every car or every pickup or every truck has these things like has engine, has an engine, has a transmission. So every one of them is going to have a engine and transmission. So and besides each of them has some special things. So for example, for cars we may care more about the gas efficiency. Let's say we want to, so we say okay, we have a value, let's say integer mpg. Whereas for pickups we care more about the storage space. But whereas for truck we care about something else. Let's say the tire size. The larger the tire, the more task it can handle. Okay, so what we know is that everything of them is going to have the common property of engine and transmission, which have already been defined by vehicle. Besides, each of them has some special things. Okay, in this case, when we define the class, say when we define the class car, let me come down. Okay, we can use this statement: public class car extends vehicle. Okay, with this statement, your car, the car class automatically inherits everything that has already been defined in the vehicle class. So automatically it will have, with this statement, it's like with you don't even need to write it down. It automatically have it automatically has the engine and transmission. So it's like, so with this extends, you can think it of as a one two words copy paste. Okay, so you basically copy and paste everything that has been defined in a vehicle class to the car class. Okay, and then so let's say we have this one, we have transmission, and then feel free to define the other things that you the other auxiliary things like the for example mpg. You only need to define mpg, write down mpg explicitly over here, and the definition of engine and transmission have already been automatically copied and pasted to your class. You don't need to worry about them at all. Okay, so this is the power of inheritance, because it allows you to reuse the definition of a class multiple times in multiple situations. But this demands very intricate design. Say when you are say working on a real project, you need to figure out, okay, how to design the hierarchy of the class. Say a vehicle has three subtypes like car, pickups, and truck. So this needs some thinking and also needs some experience. When you are a junior software engineer, you don't need to worry about this. So usually if you are in a big company, they have someone called software architecture, who is responsible for the design of the whole map. Okay, and for those software engineers, they only need to say come up with the design of specific classes and specific functions. So but the thing is that, okay, if you want to be more if you want to go higher level, maybe the management level in your software engineering company, you should go to you should first become a architecture. So this is the introduction of inheritance, and here we have a very good example of inheritance, which are here book and dictionary. So let's look at the definition of book. So here we have public class book, the definition of the book class. So it has one class member, which is the pages. Okay, so the default value is 1500. And here some of you may wonder, okay, why it is a protect, why it's not a public? Okay, so this will be clear very soon. If you forget about what is public, what is private, and what is protect. Okay, so protected. What is protected? You should go back to chapter, let me say, chapter 3 of this book, to visit. So you should be able to know it clearly. Okay, so before that, let me briefly explain the difference between them. So the most common says the definition we use is public. Public means that, okay, this variable is public to everyone. Everyone can access it. Okay, so okay, and then accessible to everyone. And then if it is private, it means that it is only accessible to itself. So anyone out of the class cannot access this variable. You don't know what is the value, what is the exact value that is stored in it. But what about protected? Protected means this, okay? Accessible to itself, and also it's the classes, it's inherited classes. So you can take it in this way, okay? In real life, if you have a house, so you only want your house to be accessible to yourself as well as your children and your grandchildren, right? So yes, this is what protected mean, okay? And also here we have some definitions like set pages, get pages, set and get functions, and then here, because we all know that dictionary is basically a special type of book, so it should also have the variable called pages, and also a member variable called pages, and also we want it to have the accessible set and get functions for the variable pages. So naturally, we when we define the class dictionary, we say extends book. So automatically it will come with the page variable. Okay, so even though we don't define over here, it's pretty much like a automatic copy and paste. That so in this class we have the member variable pages and definitions. Also we have the member functions like set pages and get pages. And also here, as you can see here, it defines the function compute ratio. Okay, so it basically calculates the ratio between the number of definitions and the number of pages. So okay, and this is the definition of the dictionary and book class. And let's go back to the words class. So where the main class is defined. In the main class, what we do is that, so we first create a dictionary called Webster, and then it print out the number of pages, and also it print out the number of definitions, and also it print out the computer ratio, the ratio. Okay, so let's look at what should the output be. Okay, so if we go to the definition of dictionary, okay, so let's say by default it comes with a page variable, which is 1500, and then the number of definitions is this one, is 52,500, and then we just calculate this value. Okay, 5, it's like 5 over 525 over 15. Let's say how much it is. This should be 30 something, 35. Yes, 35. So okay, and let's look at the output. We expect the output of number of pages to be 1500. Yes, that is what we have over here, right? And also we expect it to have the number of definitions, 52,500, and the ratio is as what we calculated. It is 35. So yes, this is the output of this example. Okay, I hope that from these two examples, which are the vehicles and cars, and also the book and dictionary example, you should be able to say what is the function of inheritance. By basically inheritance is this. Okay, is the keywords extends something. Okay, by calling extend something, it's kind of like you're copying and paste the definition of this class to the current class. Okay, and then let's look at, okay, this is the protected modifier, which I just introduced. So, and also if you go to the software engineering class, 315, if I remember it correctly, you should be able to be introduced to a new language. It's not like it's not a programming language like Java. It's basically a diagram language called UML, Universal Modeling Language. I don't recall the exact name of it. But basically, it teaches you how to draw this diagram to show the design of your classes. Okay, so, and also a relatively important keyword is called super. Okay, super means what? Super means your the parent class. So here again, let's come to the example to see what does super do. Okay, again here we have the definition of the book class, but the difference is that here in the book 2 class we define constructor called book 2 in which we basically set the pages. Okay, so then the other things are pretty much like the previous book class. So then if we look at the dictionary 2 class, okay, it extends the book 2 class, and here it has its own constructors, which takes in 2 parameters: the number of pages and number of definitions. So what we want in this constructor, we want to set the values of. So first, let's say it comes with this dictionary 2 class comes with 2 member variables. The first one is here, the definitions. And the second one is the one that we basically copy and paste from its parent class called pages. Okay, so called pages. So it has 2 member variables, and here we have a constructor that takes in 2 values, and we want to use these 2 values to adjust the member variables, which are the pages and definitions. So in the first place, we want to assign number pages to pages. Okay, this is what we want to do. So to do that, okay, here you can say that it calls super number of pages. Here super means super is basically the name of its parent class. Its parent class is book 2. So this one is equivalent to, will be translated to book 2 number of pages. So basically it calls the constructor of book 2. And then if we go to the constructor of book 2, it takes 1 value, which is the number of pages, and use it to set the page value. So here, yes, by calling the constructor of its parent class, we are copying and pasting. We basically set the variable the member variable that we inherit from its parent class. Pretty cool, right? So this is what does the superclass mean. And sometimes when you are in some other class, say for example here, you want to call the set pages function directly from its parent class. What you can do is you can either call get pages, or you can call super dot get pages. These 2 are equivalent, but in most cases we just remove super because there is no need to do that. So by typing a few words, we get the same result. Okay, So this is what does the super keyword do. And also we you may wonder, okay, so another thing that we need to talk about is called overriding. What does overriding do is this, okay? Suppose that in real life you inherit something. You inherit, let's say, a house from a relative, and so you don't like the design of the house. You want to flip the house, so you can do that, right? So it's like you inherit something, you don't like it, you change it, you override it with your own design, basically. And in Java we also have the concept of overriding. Let's say, what does that do, okay? So again, let's come to the class. We have the definition of class called thought, and here it prints a message. It has a message function, member function called message, which basically prints the sentence. I feel like I'm diagonal parked in a parallel universe. Okay, so and this is the function, the message function in the thought class. And then in the advice class, you extend thought. So basically you copy, you inherit the message function. But suppose that you don't like it, you want to override it. It's fine. You can define your own version of message. Okay. So in this way, this new method overrides the previous method. So in your advice class, you still only have one method called message, and this is the definition of the message called warning days in calendar are closer. Basically, you use this one. You use the new method to override the method that you inherit from the parent class. So override provides a way for you to discard what you don't like from the parent class. Okay, and so some of you may wonder, okay, what is the difference between overloading and overriding? Because these two names are pretty similar. So far we already know what is overriding. Overriding only happens when you inherit something and you don't like it, so you flip it. But what is overloading? Overloading is like, say, suppose here you create a class, let's say class A, and you define you define some functions. So we have public, let's say message, public void message. So you have two. So this is the first function of message, and this is the function content. And also, it's fine for you to define two functions with the same name but different parameters. Here you just create another function whose name is also message, but here it takes an integer, let's say integer k, and then you do something else. Okay, this is called overloading. Overloading means that you have two functions with the same name but different parameters. So again, overriding only happens when you inherit something from a parent class and you don't like it, so you override it. So this is the difference. And then let's look at the class hierarchy. Okay, so this is what we said by class hierarchy. It's basically this is a UR diagram. So here we can say that we first define the animal class, and then we have reptiles, bird, and mammal that all inherit animal. And then we have snake, lizard inherit reptile, and parrot inherit bird, and horse and bat inherit mammal. So this is pretty much like a blueprint graph of a big project. So again, you will need some multiple years of experience in order to be able to say when you are giving a software engineering problem. It takes you, like, let's say 5-6 years of experience for you to have the mind of creating this diagram. Okay, in the beginning of your career, you don't need to worry too much about this. You only need to worry about how to write a function and how to write multiple functions within the same class. And this kind of design has already been taken very good care of by the architecture. Okay, so let's say the other concept is called abstract class. So the abstract class is like a placeholder of a class in the hierarchy. So in the abstract class, you don't need to define anything. So it's pretty much like a placeholder, and when you are doing your exercise on my program lab, there will be 2 or 3 exercises that are related to abstract class. So you only need to remember that you don't need to create any function. You don't need to define any function in abstract class. But instead, what you only need to do, the only thing that you need to do is this. Okay, so for example, we have a public abstract class called project, and here you want to say you want to have some functions. Let's say we want to have get the barcode of the product, and so which is the string. Its type is string. Okay, you only need to provide the definition. Okay, like this. You don't need to define the exact action of this function. Okay, so the only thing you need to do is just specify the name of the function and what's the input and what's the output. The abstract class will be inherited by its like say children class or grandchildren class, and in those classes you are going to override or implement these abstract functions or functions that have not been implemented. Okay, so this is the abstract class. Let's say, okay, the visibility, you don't need to worry too much about that. Let's say, then designing of the inheritance. So the inherent class issue. So for now, you just read them. Okay, let's say the keywords like final and like static. So you just read them. But I don't require you to have a very good understanding of them, because again, this really depends on your project experience, your real world project experience. At a school is pretty hard for you to get them. Okay, so but in the first a couple of years when you go to your job, you should be able to accumulate sufficient experience to understand. So then let's come to chapter 10. So in chapter 10, we are going to learn what is polymorphism. So this is really complicated. So here you only need to pay attention to the first 3 chapters. With regard to sorting and searching, this depends on you. If you are CS or IT students, or say if you plan to take the course called CSIT 212, that structures and algorithms, 1/3 of the class is going to 1/3 of the class is about sorting, and 1/3 of the class is going to be searching. Okay, so they are going to be discussed in details in that class. So now you can forget about them, and then so we just focus on what is polymorphism. Polymorphism is, again, it is really complicated. So there are 2 ways of binding. So there are bindings at the compile time, and also there are bindings. So we have dynamic binding or late binding. Then that's, again, I would like to use examples to help you understand what is polymorphism. So let's look at the first example. Okay. Let me say, okay, over here, yes. So here, this is the design of the class. It's kind of like complicated. We have the parent class, staff member, and then we have 2 children classes that are called volunteer and employee. Then we have executive and hourly. So basically, some employees are paid by hourly rate. Some are high levels, or such as executives. they rely more on their bonus rather than their hourly rate, right? So then let's look at the definition. So the first class that we're going to look at is over here. It's called staff member. So in staff member, we have three member variables: the name, address, and phone, and then we have the the functions, the constructors and some toString functions. Then it has a abstract function called pay. Okay, so by specifying the name abstract, it means that this function is abstract. We don't need to define the details of it. We just create a placeholder out here saying that all the classes that inherit this one is going have to create have to implement the pay class, or pay function. Pay function, and then let's look at the first class that inherits the staff member. So it inherits staff member, so it automatically has three member variables, which are name, address, and phone. And over here, we can say that it defines its own version of member variables, in which it just calls its parent class constructor, and then it creates a function called pay, which returns 0 because this person is just a volunteer, so it receives nothing. And then we have employee. So in the employee class, it also extends the staff member class, and then it has its own definition of the constructor, in which it calls its parent class constructor. And here we can say the employee has a social security number and also a pay rate. And then, so in the pay function, it returns the pay rate. Okay, and then we have the executive class, which extends the employee class. So then it has an additional member variable called bonus. Okay, so it has the award bonus. So it basically say, okay, you are going to get more bonus, and then the payment is going to be the pay plus the bonus, and then this is the hourly worker. So which has an additional variable called a member variable called hours worked, and the way to calculate its rate is pay rate times hourly worked. Okay, so it's pretty much clear, right? So we have different ways so each class has a different definition of the pay function. So in the volunteer class, the pay function returns 0. In the executive class, the pay rate is going to be the pay function returns pay rate plus bonus. Whereas in the hourly rate class, the pay function returns pay rate times number of hours. Okay, so this is what. So here we have three different definitions of the pay function. So okay, and let's look at something fun. Let's look at the new here, the staff class. In the staff class, it creates an array of staff member whose size is 6, and let's look at each of them. The first one is a executive whose name is Sam, and whose bonus is this value. And then we have an employee, and whose number of hours is this whose hourly rate is this one. Then if this is hourly rate or not, let me double check it. It is an employee. Yes, it's an employee and executive. Executive. Okay. Yes, this is the rate, the employee's rate. And let's look at the executive. Also, yes, it's the rate. Okay. So the last member is the rate. So the rate of the executive is 2,000 something, and the rate of the employee is 1,000 something. And then we have another employee, and we have a hourly rate worker, okay, and then we have the volunteer, two volunteers. So and then the first one, which is the executive, is going to have a bonus of $500, and whereas the hourly rate worker is going to work for 40 hours per week. Okay, so and then it has the definition of payday. For in the payday function, for each one, it first will print out a brief summary of this staff. Okay, for each staff, it will print out a brief summary of this staff, like the name, social security number, and address, and phone, etc., etc. And then they will get the pay. So say how much this person is due. If the amount is 0, it will print out thanks. Otherwise, it will print out, okay, how much is paid, and then print a dashed line. Okay, so this is what the payday function of the staff class does. And let's look at the main function, which is implemented in the form class. So first it creates a staff object, and then it calls the payday function. The staff object, the content of the staff object is right over here in the constructor, and then it will call the payday function of it. So let's look at what is our expected output for the first employee, which is the executive. So in the payday one, we are going to print out the name of this person over here, and plus we are going to say, okay, paid what kind of amount. And then we are going to do the same thing for the employee, and the hourly rate worker. Whereas only for the last two say staff member, which are volunteers, it will print out thanks without any pay, right? So then let's look at the output of this program. So first they will print out the summary of the first person, which is the executive. So this is the information about it, and it receives 2,900 something. This is because its base salary is 24, and plus this $500 bonus, right? And then we have the second employee, third employee, they receive 1,200 something, 1,100 something, and this one is the hourly rate worker. So it's this person's hourly rate is this number, 10.55, and this person is going to work 40 hours per week. So its pay rate is like, let me say, 402.2. If I calculate, no, it's not 422. This should be 422. Okay, so yes, it's 422. And for the last two person, as what we expected, they will just print out thanks because they are volunteers, right? So yes, this is called polymorphism, because here the polymorphism happens here. Okay, when we call the pay function, okay, when we call the pay function, it triggers different version of the same function. So for the first person, because it is a executive, so it will call the executive version of the pay, so which returns the pay plus the bonus, right? And then for the second and third one, because they are just employee, for the second and third one, because they are employee, so we are going to use the employee version of the pay function. Let's look at what is the employee version of that. Yes, of the pay function, it returns the pay rate. Okay, so this is called polymorphism. It's like when we call the function, what version of the function is called is decided by the type of the object. So for the first one, because the type of the object is executive, so we are going to call the executive version of the function. This is called polymorphism. And the most common way of triggering polymorphism is through inheritance, because we have when we use inheritance, we have different versions of the same function. We define different versions of the same function, and this provides the possibility of triggering polymorphism. And the other way is called which is not as usual as the inheritance, is called interface. And so in the interface one, so again, it depends on the type of object. So in the interface one, say suppose that you create an interface named speaker. An interface basically is an abstract class where everything is abstract, in which everything is abstract. So all the functions are abstract. So again, when you are so this needs inheritance. This need okay, let's look at here. Let me see. Yes, suppose we have two classes, philosopher and dog, both implement the speaker interface. So here, suppose that you create a philosopher, and then when you call the speak function, it will trigger the philosopher version of the speak function. Whereas if when you create a dog, it will trigger the dog version of the function. So interface, this way called polymorphism via interface is they're kind of like it's kind of like polymorphism through the inheritance, because here we have the speaker interface, and it is inherited by it is implemented by the philosopher and dog class. Which has its own different version of the speak function. And then at the time when we call the function, it totally depends on what is exactly the object, what is the exact type of the object. So let me say, yes, this is pretty much what I want to teach. Okay, so yes, and this is your task for week 2. And also remember that you need to finish your exercises on my program lab on time. So for the first week, I see around 3 out of 25 students in our class who have not completed their exercises, and they don't request for let's say extension. And even though they submit their homework sometime next week, they are going to get a late penalty, that's for sure. So work on your exercises on time to get a good grade. Okay, so have a good week.